Okay, so I saved the calculus part for its own separate video. I do want to point something out. This one's worth 1 point. That one's pretty easy. This one, 3 points. This one, 3 points on E. And I'm not really even sure that the whole big, huge thing that takes a large amount of time on this even counts for anything. If it does, it's just a point. This one is basically how they mess with your mind and get you to spend more than 15 minutes, or really you should be spending 12 and a half on it, and basically ensure that you get no points on anything else. Remember, how you take this test is the hardest question on it. It's all about strategy and not overthinking, which I know, biggest challenge. And remember, when in doubt, don't use calculus. However, this one is one of the few that you have to use calculus that they don't specifically ask for something like a differential equation, or, where they don't just spell it out for you. So let's see if I've drawn this too much. Let me get this set up. And here's the thing. You need to know what's happening when to know what to do on this. So, because the big question I get is, how do I know when I use calculus? See this determinant expression? See, you're not using calculus on that. It doesn't say derive. It doesn't say anything about varying. It just wants to know. It says as a function of, okay, but it says an expression. That's usually not calculus. Unless it states something else weird. It says the word differential or integrate, or, gives you some other kind of clue. Okay, part D seems like it could be calculus. At first I thought it was. Derive an expression. Okay, derive. I see derive. That looks like a calculus word. Sometimes it is, sometimes it's not. For the magnitude of tangential acceleration of the block at the instant. Oh my God, instant, totally calculus. The block has attained a speed of v. But wait, instant. You're looking at it exactly one moment, one instant, where a block has attained v. What that basically does is fixes v for you. That makes v a one value only variable. So that's why we didn't use calculus on D. Now, however, this one, derive an expression for v as a function of t. Going through this, I knew I hadn't had to use calculus on either one of these. They seem to be flirting with it. And then I see v as a function of t, like the way it's written right here, and to me that kind of screamed calculus. Besides, now let's look and see if what's actually going on here would lend itself to, something varying in infinitesimal amounts. So they basically want this expression for velocity as a function, or speed as a function. Derive an expression for speed as a function of time. The speed of the block is, they say it, the speed of the block is a function of time after passing point P on the track. Well, at point P, let's say that's when you set your timer to 0. T equals 0, right? And then you're gonna follow it around until who knows when, till some other time, and that's gonna be T. Okay, so that right here, when time is 0, that it's coming into that ramp at v naught. That's the speed. And then over here, it's gonna be v equals v whenever you stop looking at it. That's like your initial and your final. And on that, because of your force of friction, that it's gradually slowing down in just tiny, infinitesimally small little bits. It's slowing down. So, because think about how that would look. It'd just be like gradually slow till it jumps off its track. So anyway, so let's look at that. Again, Newton's second law problem. I'm not going to write Newton's second law again. They should get it by now. So I'd say mass times acceleration equals, now, what's causing it to slow down? Well, that would be the force of friction. Because on these, imagine an ideal system. If I didn't have this frictional force, if that were smooth on the inside, it would just it'd go on forever. Nothing would slow it down. That speed would be constant. We wouldn't really need to do it as a function of time because it would be constant speed because it's perfect. That's not the case. So we're going to say mass times acceleration equals your force of friction, which the part I erased, hopefully you remember, force of friction is normal force, and then remember that'd be mu m v squared over r, and it's a negative. If you remember, I had to erase this because I think I'm going to need the room. Actually, I'm going to write this up here. So your net force, your mass times your acceleration, and it's going to be the acceleration that's varying, or that, you know, well, anyway, force of friction is causing it to vary. So it's going to be negative, I'm just going to put the mass front, mass mu v squared over r. So you should see that the masses cancel out. Okay, and this acceleration is going to be varying. So dv dt equals negative mu v squared over r. Hey, if you have this negative sign, that's 2 of your 3 points right there. Now, as far as I can tell, this next part is your third part. Now, when you're dealing with calculus, and forgive me, I'm going to do this in pre-cal, like making this really kind of overly easy, maybe. You want to basically get, these both need to be in a numerator. Okay, easy enough. Let's get this dt in the numerator over here. So we're going to go dt. I like to put them in parentheses. That's my own thing. So let's get rid of dt over here. I'm just putting this in parentheses to remember that's what it varies by. I'm going to end up writing over some of this. Now, let's get what goes with that over there. So v squared. So I'm going to go v squared, right? And I'm going to take that negative with me. You'll see why in a second. I don't think they did that in the answer key, but I like, to me, just because this gets to also, oh, by the way, this also turns into an algebra nightmare. Okay, that's ugly. Let's rewrite it. I'll rewrite it in green. So I'm going to write this as v to the negative 2. Oh, I'm sorry, negative. I forgot my negative. Negative v to the negative 2 dv equals mu over r dt. Okay, so we want to get rid of those little tiny curly deltas, the d's, right? So I'm going to do this area under the graph called the integrand. Now, what's special with these is I want to say when I start looking at it to when I stop looking at it. Let's start with time. It's easier to see. We're going to start looking at that at stopwatch 0 till whenever we stop looking at it. Well, whenever the stopwatch reads 0, remember, your speed is v naught. And we're going to look at that till we stop looking at it, which is v. So that's saying from where to where. That's important that you put that on these because it's science and, you know, you need to know when you're looking at it. You can do it with a constant, calculus people, but it's way harder. Just, you know, set your parameters here, you know, your limits rather. Okay, so this is the power rule, but backwards. It's, you know, like the whole, so instead of subtracting 1 right here, I'm going to add 1 to the exponent, so that's negative 1. I'm going to come over here and divide this by, so change that to negative 1. I'm going to divide everything by negative 1, so what you're going to get is, I'm going to go ahead and put it back as a fraction because you'll see why in a minute. Actually, I'm going to do this over here. Therefore, 1, oh yeah, when I negative 1, these negatives cancel out. 1 over v. Then I'm going to put this line right here. All this line is because I've now gotten rid of the troublesome calculus stuff. This is just to remind me of something that I'll show you in a minute. V equals, okay, so let's come over here and do the same thing. Now remember, this has a tiny goes t to the 0 power. So we're going to add 1 to that, so it's going to be t to the 1, so it's 1. I'm going to take this and divide this by 1, which really doesn't do anything. So, I mean the 1, it's just, you know, anything divided by 1 is itself. So we're going to end up with mu times t, because we got that t over 1. Yeah, the t, see, the ghost t. Okay, over r. And I'm going to put this line right here to remind me I'm going from 0 to t. I will switch colors again. Okay, so basically this is your initial and your final. And all of this that we just did is implicit of change in. It implies a change in. So basically I need to do my final minus initial and essentially plug these two things in. Think of it that way. So I'm going to have 1 over v minus 1 over v naught equals, oh, this one's easy. See the 0, we don't even need to worry about it. So we're just going to go mu t over r. Okay. By the way, at this point, I think they stopped counting points, but let's go ahead and finish the algebra nightmare, shall we? Let me get some room. This is also, by the way, this last part I'm doing, Really? This is what you say for the end. You don't do this unless everything else you can possibly answer on this test is answered. That's the part I'm doing now, because this is pathetic. All right, this is what a spreadsheet's for. Okay, sorry, my dog is going nuts for some reason. Okay, so basically this is going to give me, I'm going to add this to the other side. See, because I add, subtracting, added, I think Miss Pierce is off. Okay, so you get this, right? Oh, wow, what fun. Common denominator, yay. So I'm going to end up with, so therefore, you're going to have mu t v naught plus r over r v naught equals 1 over v. Flip the whole thing over. Therefore, v is a function of t. And if you don't understand the algebra, you don't remember, I'll help you, but really, let's not do that. Equals, because again, this doesn't count. I mean, maybe, but not enough to do. Sorry, College Board. I would like to be a grader for you. Mu t v naught plus r, but this is ridiculous. So that's your answer. Please, all the part I didn't read, do not do that unless you've answered everything else on the test.